just give the overview, not complete, because if I give complete knowledge means it will take again 4 or 5 hours. So I just give the overview since I already covered everything in separate videos. Today I'm going to give the overview, and later I'm going to cover the interview questions. What kind of interview questions will be asked in that by the companies. So okay, Docker. So Docker is a continuation tool which basically used to create the containers. But before Docker, uh, what we are going to use, we were using the virtual machines to create to deploy the applications, right? So if we use that kind of strategy, and if we deploy the applications, then the applications may not work. Basically in the real time, we are going to face some issues, big issues, like when developers is working on some application, and they will deploy the application on the different environments like dev, test, UAT, and production servers, and the application is working on the non-production servers. But when it comes to the production servers, the applications may not work due to some what kind of issues, compatibility issues. Maybe the application, the production server, right? In production servers, we always used to maintain the latest patches. So dev test, we are not going to care much on these servers, non-production servers, because they are just for the testing purpose, right? So we don't maintain. Of course, we will maintain the latest update, but still, production we will concentrate on the production servers because those are live servers. So when developers are deploying the application on the non-production servers, the application is running fine, working fine. But when it comes to the production server, even though when the first time they deploy the application production servers also, the application is working. But when developers won't stop by the single version, right? They try.
Sorry for interrupt, Shriki. Actually, there was a issue with my network. Can you please
Okay.
repeat again?
Yeah, sure, definitely. Hmm. Okay, actually, Docker, why Docker came into the market, why people are adopting this Docker technology means, before Docker, we are using servers only, but when it comes to the deployment part, developers, developing the application, they try to deploy the application the different environments like a dev environment to UAT, test, and production servers. The when they deployed the application on these servers, the servers is working fine, the application is working fine. But developers won't stop by the single version, right? They will keep on update the latest versions. Just like take example WhatsApp, they won't stop by the single version, right? They are still developing. Like previously we are able to only do the chatting part, but later camera is came, and camera functionalities came. Then status, we can keep the status. Then we can also delete the messages. So they are updating to the with the latest functionality or features, right? So the same case, when in the real time, developers will try to develop the latest new features. When they deployed the one version on the servers, it's working fine. But when they try to deploy new version, the new version, it is working on the non-production servers. But when it comes to the production server, the application is not working due to the reason, maybe anything. Majorly it comes to the compatibility issues. And I mean the version which is they try to deploy the application on the servers, the application may not support the latest version. I mean previously it was working fine, but later they updated their servers, or they installed the latest patches. They upgraded their system. Now they try to deploy this latest version on the servers. Then the application is not working due to the compatibility issues. So the support team will say our end everything is fine. Mistake only from your side only, please check. So they will say, like developers will say, like we already deployed our non-production servers. it is working on the development or testing servers. So now it is not I mean, issue is with the production servers, means the problem with you only, please fix the issue. Like, I mean, there will be some kind of argument between the team, right? Because no one knows the exact issue by production team, because there may be issue with the compatibility issues. So there will be some argument between the team. They are unable to find the exact bug. What is the exact bug? Because previously it was working fine, but now it come when they try to deploy a new version, it is not working. So that's why, we, there is no guarantee, like, even if we use a high level complex environment, still there is no guarantee to, like, no application will be without error, they will be working fine. No, there is no concept like that. Because the versions, in the market, we need to upgrade to the latest environment. So the main issue is environment. The main issue is compatibility issues. The second issue is, even if you deploy, I mean, application is working fine on all the environment, but when it comes to the resources side, suppose if I want to any DB server, I will create a virtual machine. I will create a virtual machine. I will assign some 4 GB RAM, some 2 core CPUs, like that. I will be giving the some basic resources to that server. But there is no guarantee, like the server is is going to use full resources on the server. Maybe the application may need only 20% of memory, or maybe 20% of CPU, but the remaining resources will be wasted. But Ravi, are you there?
Yes, Ricky, I
Yeah.
am there.
So, uh, what, where I was. Huh. So, even though they, created a server, but there is no guarantee there that, the application will be fully utilized, because that application may use only 20 to 30% or 40%, maximum 50%, but remaining resources are wasted. Still, okay, what I will say, I will do, okay, the remaining, I mean, 60 to 70% resources are wasting. So why, what I will do, I will install another application on the server. Like, I have a DB server. Now I will install a web application server on the same server, same server. So that, we can use the use the server fully. I mean, I will fulfill the full resources on the server, and like a DB consuming 40%, and the application maybe consuming 40. Okay, 80%. Okay, that is reasonable, because just 20% is wasting resources. That's okay. I'm okay with that. But when the application load goes high, suppose in the DB server, people, I mean, the application is backend is DB, right? So when they try to number of people try to access that application, so the application load may be increased, or DB load also may be increased, right? So if that memory resources are reaching a high point, the service may crash. So then later you will try to create another, okay, you will try to increase your RAM, but later point in time, the resources may be decreased, after,
Okay.
if the users are not and there is a traffic, but there is not completely there is no fully traffic, right? The traffic will be in the daytime, the traffic will be high, and the nighttime the traffic will be low, right? So, I mean, it depends on the timings the server will you going to use the resources. So in case, okay, the server is working fine. I mean, the resources are fully utilizable. But if we face any issue with any DB or server, or any application server, what you need to do, what you are going to do, you need to fix the issue, right? Database or any web application, or whatever the application installed on your server. If you want to fix the issue, then you have to take a downtime for that, whether your DB or application. You need to take for the both, because you installed two services in the same server. If you want any downtime, you have to take downtime for the. Okay. Okay, so you need to take a downtime for both application, I mean, even though issue with a single application. That's why in the real time, what the people will do, so they will create a separate service for the each application, so that even if we get any issue with the particular application, I mean, So
Am I
that's why,
able to?
yeah, yeah, I can hear you. So that's why we in the real time people will created servers for the each service.
Yeah, hello.
Ravi, I can hear you. Hello.
Hello.
Okay. So that's why in the real time people will maintain the separate server for the each application, whether it's a DB or web application or uh, uh, web servers or applications or whatever the servers they will maintain for a separate server, even though the resources are wasting. Still they will try to create, because when we face any issue to the particular service, we need to take it down for the particular server. But if we have multiple services in a single server, then we need to approach for the each team, like application team, database team, and whatever the services you have installed on the server. We need to approach for the each time. We need, I mean, then we the three teams need to be accept for that particular downtime, right? So that's very complicated process if we have installed the multiple application in a single server. That's why in the real time we will maintain the separate server for the each service. Even the resources are wasting, but still that is the best way to uh, getting out of the issues from real time. Ravi, hello.
Yeah, yeah, Srikanth.
Yeah, okay. So here yeah, okay. So that's why that is one of the drawback in the if we use the server VMs, because we are not fully utilizing the resources. We are maintaining that separate servers for the each, even the small, for the small application also we are creating a high complex servers, a 4 GB RAM or 8 GB RAM. Even though if we increase the resources, but there is no guarantee like the servers will keep on utilize that resources. It depends on the time. It depends on the time, and depends on the number of people are accessing the applications. So in the daytime, people try to access the application, but in nighttime, nobody. I mean, most very less people will try to access the application. So at that time, there is no need of that much resources. So that's why this is the one of the drawback. One is the one point compatibility issues. The second point is resources are wasting in the VMs. Then third point is uh, what is the third point? What is the third point? Yeah, and so license part. Even we create a virtual VMs, we need to take. I mean, we need to pay for the VM, and we need to pay for the OS, whichever the OS you are installing. Suppose if you are installing the Windows OS, then you need to Windows OS are not free of cost. You need to pay for the license, and you also need to pay for the patches or latest version. Of course, it will get to when you take the license. Another one is resources. You need to pay for the resources also. If how much RAM you are using, how much CPU you are using, how many networks or how many IP address you are using. So you need to pay for that vendor. If you are using VMware vendor, you need to pay for the cost for the resources, and you also need to pay for the application. I mean, server side. So like OS.
It is kind of pay as you go.
Yeah, of course, pay as you go only. But yeah,
Mm-hmm.
you need to pay for how much you are utilizing, right? So uh,
Mm-hmm.
so that is not we need to pay for the license. It's for the to maintain the one server. It's really high,
Mm-hmm.
huge amount when it comes to real time, right?
Okay.
No, I mean, if the developers want to test just for testing purpose, they need to create application for web application or database or whatever the services
Mm-hmm.
they are going to use in the real time. So they need to create a servers for each service. So how much for each server? How much we going to charge? You need to pay for the VMs cost and the resources cost, and you need to pay for the license cost of the OS. So three servers means that you need to pay for the three. Even the MySQL, if you are using any kind of DB, you need to pay for that. You need to pay for that license also. MySQL is also not a free. You need to pay for. You need to take a license for that. Means
Mm-hmm.
just for testing the application, we are creating these many servers, and still there is no guarantee to the application is going to run without any issues. because the application may run on the may not run may run on the non-production servers, but may not run on the production server due to the patches. Maybe the application, the latest version is not taking, maybe the OS is not fully updated. So the reason, anything, the reason might be anything. So these are the
Incompatibility.
these are the main drawbacks in we are facing in the virtual machines. Just for
Okay.
single purpose, I want to test application. For that also I need to create a new server. So that's why this is really high complex environment for in the enterprise level. That's why Docker came into the market. Docker, why people are adopting, even in my organization. So we are not using VMs. I mean, of course we are using VMs for the to install to create the containers. Our application is deployed on the containers only. It's $1 million project, but that application is deployed in the containers only, free. We are just paying for the servers, just 10 to 15 servers only. That
Okay.
so the thousands of crores of project is deployed in the Docker. So funny, right?
Mm,
Yeah. So that's the, in that level Docker is developing in the market currently. So Docker advantage is what we are discussed. One is compatibility issues. So if you install the Docker will say like, don't worry about your underlying infrastructure, whether you maintain updates or whether you don't maintain the updates. You don't, doesn't matter. You just
mhm,
deploy your application on my containers. I will take care of everything. Just concentrate on the deployment part or concentrate on the development part. What are the high level application, just concentrate on the high level part. The lower part I will take care, because Docker has that kind of capability to maintain the your infrastructure. And in each
okay.
server you can create multiple services, multiple containers in single server. Each container will act as a isolated containers. I mean, there is no, as I told you,
No,
we will be.
can you please repeat it?
Yeah. So in what I said in virtual machine concept,
Mhm,
you want to make a fully utilize your server. Then what you are trying to do, you will try to install two applications in single server. But in case if
mhm,
you face any issue with that particular service, you need to take a downtime for the both services, right? Because we need downtime. Downtime means we need to shut down our server. So shutdown means that
exactly.
application will be going down. So we need to approach
Going.
your two teams. Whatever, how many
Okay.
applications are deployed onto the servers, you need to approach to the two teams. Like one is application team, another one is database team. So they need to
Mhm,
mutually accept that our downtime. There is no
mhm,
guarantee like we need to take a particular time, because one
mhm,
team saying, oh, we are not able to give the by this time, or this team saying we cannot give the downtime on this time. So they mutually
mhm,
accept the downtime, because they need to fix the
mhm,
issue to the particular service, even though the issue with the particular service, but we need to take a downtime for the two services. That's why in real time they will create a separate VMs for the each application, because whenever they get the issue, they will try to take downtime for that particular services only. So okay, so here in the
No, no, no.
Docker.
Here is you mean there are there are two services. Okay,
Mm,
then they will create two virtual machine for
yeah,
one application for one server
yeah.
and
For
another application
database,
for another
for
server.
see, for the database and application, they can't install in the one server, because those are two different applications. Database some are different service, and the web application is different service. They will create a separate servers for the separate server for.
But
Mm,
they will create separate server, but they have to invest more amount for that, right? For two
yeah,
servers.
of course, that is what I'm saying. That's why people,
Mhm.
for the testing purpose, they even though they maintain, they will invest on those two server, but still there is no guarantee to, like, the application will successfully deploy, because even though the first
In
time.
Docker.
No, I'm talking about the servers, VMs. I'm
Mhm,
talking about the VMs. Even though they
mhm.
will purchase, invest on those servers, but there is no guarantee to, like, the application, the services will run without any errors or any issues.
Okay,
First time they
the
will run,
service
but
is run.
later they will try to, create deploy another version. That at that time maybe we'll get the issues, and it is really
Mhm,
complicated to go revert back to the changes. That is really
mhm,
complicated way. Okay, fine.
mhm,
So in the Docker, you just need to install Docker service, server on your
mhm,
server, then create a
mhm,
containers. Each container will act as a separate server. So
Mhm.
you can create a separate container for database. You can create separate container for the web application. You can create a separate application for the backend. So you can, I mean,
Mhm.
in single server, you can create as many services you want. Each service acts as independently. There is no communication between the service. If you get issue with that particular container, then restart the service. That's it. It doesn't affect with that another service.
Even though server goes down.
That is different. That is different. If
Oh,
the
okay.
developers want to test the application, so what he will
Mhm.
do, he doesn't create a separate VM for that. He will just create a
Mhm.
container. He will deploy the application on that container.
Mhm.
That's it.
You mean for testing purpose only it was very
No,
useful, right?
no,
Hmm?
not like that. In nowadays
Uh-huh.
we are in real times also we are using. And
Okay.
when not real time, because mostly Docker will be used for the testing purpose only. And
Mhm.
real time we will be using Docker images. We'll create a Docker images, and we will
Mhm.
share. We'll keep in some hub. Then
Mhm.
for real time we will be using Kubernetes or some orchestration tool.
Okay.
Most people will be using Kubernetes only. So I will come
Mhm.
to the later when I discuss with the Kubernetes. Then I will be discussing more deeply.
Mhm.
So basically Docker it is just a service, just like a software. Docker is just like a software, but it will
Mhm.
create a containers just like a VMs. If I talk about high level part, in vCenter we will create a virtual machines, right? Here Docker
Yes.
just like just like vCenter, just like, imagine like a Docker is a service where we can create a Docker containers.
Mhm.
Have you ever installed a virtual VM VM software? I mean, there is a software, right? VMware, I think something, I don't know exact name. Software, we will create a VMs, right?
Tool.
Tool. I'm talking about tool. That software I'm
Mhm.
talking about.
Mhm.
We will wait. Download.
Workstation or VMware VS Code tool if you are
Workstation.
saying that,
Yeah,
right?
VM workstation. So we to create VMs, we are
Mhm.
installing
Mhm.
workstation, right? Same here also. So to create
Yes, yes.
containers, we are
Mhm.
installing the Docker service. So by using Docker, we can
Mhm.
create a containers. Like we can create any type of containers. So in that we
Mhm.
can deploy our application. We can test our application without creating without there is no need of high complexity infrastructure. Here
Mhm.
the main advantages the main advantages, uh, there is no compatibility issues. Why there is no
Okay, got it.
compatibility issues? I will say, okay, there is no,
Mhm.
because Docker will take care of everything, your underlying infrastructure. You maintain the updates or not, it doesn't matter.
Mhm.
It
Mhm.
Docker will be having the separate layer to maintain your
Mhm.
application. The second one is resources. So here Docker will be using the host machine.
Mhm.
You are installing the Docker containers on your host machine. Oh, do you mean host machine? Host machine, your
Host
server.
machine means
Your
our
server.
server.
Yeah,
Mm.
your server. So Docker container, even though you're creating containers for the different services, for that containers we are not assigning any RAM or CPU, because Docker will take RAM CPUs from your local machine. So
Mhm.
how much you are utilizing, how much load it has taking, that much load it will take from the host machine. We are not giving separate RAM CPU for the containers. So we are saving, because we are not dedicatedly attaching resources to the container. It will take as per the load. So that is one advantage. Here there is no kind of wastage of resources. Of course you
Mhm.
need to maintain uh, 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 high amount of RAM CPUs on a local machine. Since you are new,
Mhm.
your even Dockers are very lightweight. No need of that much. You can run on your 2 GB RAM or 4 GB RAM also. It doesn't matter.
Mhm.
Very lightweight. You can create multiple applications by using the containers. So second one is resources. Here resources are not going to waste, because it will take resources from the host machine. How much load it is
Mhm.
there, it will try to take from the host machine. There is no constant fixed RAMs for this container. And the third point is what? OS. Maintain the license part, right? We discussed in VMs we need to
Mhm.
pay for the VMs and the resources and for the license part, right?
Mhm. Mhm.
Here there is no need of for license part, because Docker is free. Containers are very
Mhm.
yeah, free everywhere. No need to. If you want to doc, let me show you example, practical example. See, if I want to create any some CentOS, I will create to Docker run -it my machine, my machine. I will give some name, uh, Alpine. I will give CentOS. That's it. Simple. Within seconds, now my OS is ready.
Oh my God.
Mhm. I what I do, I have a server. I have a server. I will deploy my application on this server. If I don't want, I will just delete the content. See, 10 seconds, not even 10 seconds. My content is ready. I can go to the
No, no. It means that image is ready or something.
containers.
OS is installed.
OS means this is
Okay.
lightweight. These are the
Uh-huh.
lightweight containers. Docker
Mhm.
PS. Okay, I'm inside the container. See, I'll be having the same directory structure which CentOS is having.
Mhm.
See, now I can deploy my application here. So I will go out of the Docker PS. So my CentOS is ready. Next, what I will do, I will create an Nginx. Nginx is a web application. Nginx. Simple. That's it. My Nginx is ready. Not even 1 second. My Nginx is running.
Mhm.
Let me wait. I will show you. Okay. See, now I can able to access my Nginx. Let me show you the magic. -p 80 port 80 port. Okay, fine. Let me queue the web one.
86 or 80?
86, 86. I mean, 80 port is already running on my machine, so that's why I given different port. See,
Mhm. Okay.
wait. It is not running. Wait. I will show you. I will show you that my system has some problem. Oh my God, it is running. Oh my gosh, it is taking long time.
Do I need to install these Docker?
Very simple to install. Let me show you that.
Mhm.
Just single command to install Docker.
In PC? I mean, I am asking like in
Yeah,
PC.
yeah. But Windows is not support to in Docker
Oh,
because
Windows not support.
you need to install the you need. I think Windows 10 you need to install.
Windows 8 is fine.
I don't think so. Windows 10, Windows 8 will work, but it is not recommended to use the Docker on the Windows machine.
Mhm.
It's come slow machine.
I mean,
Why?
okay, then that is
You can install the
because
yeah.
how I can check.
Okay,
Chinna, why are you shouting? Class is going on here.
okay, okay. I just log into the cloud server. Let's see. Yum install Docker.
Yum install Docker.
Simple.
What? Yum install Docker.
Yeah,
Okay, this is installed.
yeah. Docker
Okay, okay.
version. Yeah. See.
Which
Simple.
version you want, we can install,
No,
or automatically it will take
it will
in and
install
out.
automatically. It will install latest version. Simple, right? So let me
Okay.
create Nginx Docker run -it d name ng, just giving some name. What is the image name? Nginx. I need to
Okay,
open.
that image name is Nginx, huh?
Yeah. So I will give the 80 86 80. Mm, done. Okay. Now I will access that using the IP. What is the port number? See, simple, right?
Okay. What you said, Nginx, is it a kind
Web
of
application. I mean, if you have any HTML application, you can deploy in the Nginx in Nginx container. You want to install Docker database, you can do that as well. Run -it. I will give
IT care? What is the IT?
IT
IT
means
and IT
interactive mode. Interactive mode.
interactive
Yeah,
mode.
interactive mode. D for means detached mode. I mean, if you don't mention, you directly go into the log into the Docker container. I don't want to do that. So I'm just giving the FND. See, let me show you that. Uh, I don't give D. So I will directly go to the whenever the content is created, directly go getting inside the container. So what I will do, I will so I will go for the Redis database. Message. Done. I simple. My Redis content is created within seconds.
Where I can see that.
Wait, see, I'm directly going getting inside the container. So if you use D, then you will be container will be created, but you are in the same host machine. Now I'm inside the container. So I if I go out of the out of the container, use the control PQ. So I'm outside the container. So now I'm in host machine. If I want to see the running containers, Docker PS, see, Redis Nginx is running. These are I created before my work purpose.
Okay, yeah. Here we can see the created
So these are the
36
different.
of.
These are independently working. Independently working. If you get any issue, then you can. In the real time, when we are dealing with the Docker containers, we don't troubleshoot the part. We directly recreate the containers. Instead of wasting of time on the troubleshooting, it's better to create a new container. That's it.
Okay, but what about the data?
Yeah, exactly what I was trying to say. So we can persist our data. If you, I mean, this command will create the content, but if you create any data inside the content, the data will be destroyed after if the container get any problem. So that's how we can persist our data. We need to use the volume section for that. So we can use -v. -v means volume. Where I want to persist the data, I want to persist data in OPT directory. This is my host path, and which path I need to persist to. The colon after colon, this is container path. So I want to persist data home /home means whichever data we create in the home directory, the data will be synced with the host machine path in OPT directory. So let me show you that. I will give some name. I have already DB, right? DB1. I will give DB1. Wait, I will show. -v /opt /home. Okay, already allocated 86 port. So I will give
Port is
87.
already allocated.
See, I will go. I will remove the D. So I want to getting inside the container whenever create. Oh shit. So container is created. Yeah, seconds 6 seconds ago. I will log into the container to use to log in. use docker exe -it, uh, use the executable shell. Hmm. See, go
What
now.
is that ID or what? Something like
Which one?
7B,
Which
that one 7B64
that
E4
is
double four.
container ID. Container
Okay,
ID. Container ID.
okay, okay. We can through image also we can
No, no.
log in.
Images are just like ISO file. See, if
Mm-hmm.
you want to install OS, what we will do? We will download the ISO file
Mm-hmm.
for that OS, right? Do you mean?
Mm-hmm.
Do you know ISO file?
Yeah, yeah, I know. I suppose.
ISO file. We call it the image. Technical term is
Mm-hmm.
image. First,
Mm-hmm.
if see, I have some no OS laptop, I want to install the laptop. I want to install the OS. So what I will do, I will download the image, micro
Mm-hmm.
Windows 8 image into the pen drive. Then I will insert to the as I mean, I will keep that OS into the pen drive. I'll keep insert into the laptop. So from that way, I will
Mm-hmm.
install the OS.
Yes,
So
yes, yes.
image means we just an image. It's a template. By
Yeah, I
using that
got it.
image,
Got
we
it.
will create in the container. So that's the
Yes,
image
yes.
meaning. So now I'm
Mm.
inside the container. So where we have first
You can simply say like server name, container ID in the sense.
server name.
Like,
Yeah, server
okay.
name. Where yeah. So I persisted data. So OPT with home. So whatever the data is there in OPT directory, that data will be synced with the home directory. Let me see that ls home. See, actually it's an empty container, but my data is synced with the container data. See, this is data not exist in the container. It is getting from the host path because I given the OPT directory.
Mm-hmm.
See, OPT directory data. So in my
Mm-hmm.
lab server, I have a OPT directory. In OPT directories, I have some data. So that data is synced with home directory. So if I created any file, touch Ravi, I will create a Ravi file. See, I will do ls. Where is Ravi? Oh, okay. Let me go into the home directory first. So I will create a file, Ravi, ls. Where is Ravi? See, Ravi is there. Now I will get out of from the container. Control PQ.
Mm-hmm.
So I'm out of the container. Now I will go to the OPT directory. See,
Mm-hmm.
Sri Ravi file is there or not? See,
Yeah,
I
yeah.
didn't create on my host machine, but the data is syncing with the container because I created this file inside the container. Even if I delete the container, let me delete the container. Docker rm hyphen. Okay. What I will do, I will recreate the container.
Mm-hmm.
This time same, I will persist the data. Same, I will give the same path home. I will
Mm-hmm.
create, I'm attaching the same value, I mean this value. Hmm. Now we'll go inside the container. Again, same data will be there.
Okay.
Docker exe -it bin. Hmm. If I go to, if I see in the home directory, see Ravi is there, right? Same data.
Mm-hmm.
So in this way, we can persist our data. Even though content is destroyed, our data will be remain persisted if we use the volume section. Understood?
Mm-hmm.
So it's very simple, right? And you may get one doubt. See, here also we are using the same infrastructure like CentOS or any infrastructure. So how the compatibility issues can be reduced? You may get this doubt. Since
Yeah.
because if you install your application onto the on top of your OS, you can't reshare you can't share your OS right to the other user because
Mm-hmm.
it's installed on your server. I mean in OS, how
Yeah.
can you share that OS to the someone else? It's not. It's impossible, right?
Yes,
But
yes.
in Docker, you can share your OS to the different multiple users
Mm-hmm.
by using the Docker file. So Docker file here we are using ready-made images. Here we are
Mm-hmm.
using ready-made images. Nginx is ready-made images already available in the Docker Hub. So it is taking from the it is pulling from the Docker Hub. But if you want customized data, your own data, see you have
Mm-hmm.
some application is there in host machine. I don't want to
mm,
deploy after creating the container because it will take a lot of time. Again,
mm,
installing services, again deploying the application, exposing the port, starting the service. It's very complicated process. What I will do, I will create a Docker file. So in Docker file, I will mention everything.
mhm,
Wait, I have a document. Docker file. Yeah. So this is the Docker file. It has some properties from comment and copy, add new. I can't explain everything. Docker file example. Yeah, here it is. There. See, this is in my Docker file. What I will do, I don't want to use a ready-made image. I will create my own image. So
mhm,
this is my Docker file. I will use the one platform. Of course, you are creating your own image means you should have some platform, right? So
mhm,
I give an Ubuntu, or you can give any CentOS or some any OS you have. Then maintainer, you can give the your name, mail ID or something. Just it's a metadata, you can say. Here you are installing Git. So whenever you create a container, you need to get some packages inbuilt. So that packages you can mention here. apt add get. So whenever we create image, if we create a container, Git is pre-installed because we have use a customized Docker file, right? So
mhm,
working that to pt copy. If you want copies from your host machine to container, you can use this environment. Okay, let me use this file first. You need the name should be Docker file only. You can't give any other name. Oh, here is it is already there. Oh, okay. This is my Docker file. I will create this. I will create the. I will convert this into image.
mhm.
Docker build. I will give some name to image. My image. Just dot. Dot means current directory. Okay, fine. Uh, I don't have much space, so that's why I'm keeping here. So if you use this one, you
Mhm,
will be image will be created. Image will be created. So that image contains some file. Copy some file is there. My host. This is host path. This is container path. So
mhm,
I'm copying file one into the home directory. Then I'm downloading some package, some file into the home directory. I'm installing Git. I'm giving some name.
mhm,
This is Sreekanth. I'm giving some container. I'm exposing this IT port. So if you the
mhm,
image will be created with this functionality. Then if you create a container, if you get inside the container, in this path you will be seeing these files, file one, or this star file, or Git is already installed, like that. So this will be
mhm,
most of the people in the real time, they will be using this Docker files only. So because
mhm,
they have the application on your host machine, they will copy. I mean, they will deploy the application. I mean, they will copy the application into the directly into the image. So whenever the image creates, the application without any configuration, because we are already doing configuration part in the Docker file itself. So no, later we no need to do anything because if we are mentioning a fully in Docker file, the container will be created by with this functionality. So
mhm,
Docker image will be created. So if the application, I mean, application, obviously it will work fine. And if someone wants, if some other developer wants the test the application, so what will this fellow do? This developer will do. He will just share this Docker file because if he create his own Docker image, the maybe the application may not support. Maybe we would get some issues.
mhm,
We would get some kind of issues if we create his own image. We are not sure, right? So what we do, this container is already working because I mean, if this Docker file, if we create image container by using this Docker file, this application is working fine. So what you will do, you will share this Docker file. Don't use any other images. Just use my Docker file and create the infrastructure. This is same for everyone. Whoever use this Docker file, they will get the same infrastructure, same updates. There is no less updates or more updates. They will be having the same updates, so that this can be shareable. So everyone will be on the same page. There is no other extra functionality, not like that, because they're using the same Docker file to every user. There is no thing like it is working on your mission, but not working on my mission,
Mhm.
right? Because they are using the same Docker file. This can be shareable. And not only
Okay.
Docker file, if you don't want to share your Docker file to anyone, you can share your
Uh,
image means by using this Docker file, we can create the Docker image, right? You can share that
mhm,
image to the other users. They can push to the Docker hub. Docker hub,
mhm,
let me show you that Docker hub. They can push images to the Docker hub, and they can pull that image from their local system.
mhm.
These are the images I push to my registry. This is the public repository. You can, I mean, we can create a private repository also. So these are the images I push to like that. So we can push, I mean, these images can be downloaded, and they can create the content directly. There is no need of configuration, because the already that image is already having this functionality, this Docker file. Here, here we already creating the configuration in the Docker file itself. So user just need to download and just run the container. The application is up directly, no need of configuration. So in that's where we can I mean, reduce our compatibility issues across the multiple environment, because this image can be shared to any environment. They'll be using the same image to every environment. There is no point like they need to create another image and deploy the application again. If they do like that, there is obviously we are approaching the same old method, like creating the servers and deploying the application on their own different servers, and they are maintaining the updates, latest update. The application may not run on that some environment. So if we do the same kind of strategy here, so we'll be getting the same issues. Of course, we don't get issues here because we are not going to update our Docker images to the latest version. So we'll
Okay.
be using the same, but I'm just saying we can share our image to everyone, so that
Okay.
they no need to create again. See, let me give
Mhm,
an example. I have a server, the applications or everything is configured on the server. If I want same kind of set of infrastructure, uh, I will just give the instruction. I will create a document. I will say to the some other user, just create the same set of sa- mm, infrastructure. So what you will do, you will create a server, I can install the services, I can configure the services like that. You will do time. It's a time waste, right? So what you will do, just
mhm,
to share this image and run the container. Infrastructure is ready within seconds, like that.
mhm.
So that is the Docker file. Actually, I discussed a lot in my session, but this is for only overview, right? So that's why I'm not giving a full description. So in the Docker file, I have created a lot of for each topic. And the next topic comes to the,
Did you share these or not? It's shared with
it's
anyone.
shared, it's publicly accessible. I given access, right, to you. Wait, uh,
You given
Shaker. Okay, give me your mail ID.
Ravi dot
Ravi dot. Yeah, I
and
given.
niche. You can.
Okay, done. Wait.
Mhm.
You'll be getting a notification, or you can share. You can click on this link. Hmm. And volumes, I told you volumes to persist your data even after destroying the container. You can save your data into the local machine. There
Persistive
are
in the sense to
persist
keep
means
safe.
safe to
Mm,
keep the
mm,
safe. So
mhm,
I mean, you can. I mean, there are two approaches in Docker volume. One, you can share your volume to the uh, content to container. I mean, each container will be having the same volume. so that if you update anything on the volume, the data will be synced to the every container. So see, if you have created a volume, one volume, and you shared that volume to the, and that volume is attached to the multiple containers. In any container, if you modify any, if you create data, if you modify anything, any container, the data will be replicated to the all the containers. See, if in one I have three containers, I have one volume attached to the same containers. Volume. Wait, let me show you. So these are
Which
the.
OS you are using? That laptop OS?
This is Mac.
Okay, you are working Mac.
Okay, these are the my containers. Uh, this is my volume.
Mm,
Now this volume can be uh, attached to the multiple containers. Same container. Sorry. Same volume attached to the multiple containers. What the hell? These three containers attached to the same
mhm,
volume. So if you modify
mhm,
anything in this
mhm.
container, like
That will reflect in
uh, uh,
okay. The same
all
will
the
be reflected for another.
like that. So this will be
Mhm.
reflected on the same on the because it is shareable volume. This is
Okay.
shareable volume.
Whatever we will change in one container, that
Uh,
drive,
mm,
that will reflect in the
all the
which are connected the drive.
associated with that
Mhm.
value.
Okay.
So
Okay.
in that way,
Okay.
we can. This is one approach, and another approach is if even you can uh, see if the container is destroyed, no problem. We this volume attached to the
We
remaining container, you can persist data.
mhm.
But if in case if you
Okay.
if these three containers are destroyed, in that case, you can go for the host machine. When you can persist data
Mhm.
with your host machine like
Mhm.
this.
That also we can do.
Yeah, of course. Two approaches. I explain in deeply in my
Mhm.
session. So that's why I'm
Mhm.
not explaining here. So here we can even the content destroys that data remains same. You may get one
Mhm.
doubt if we lose if the content is, I mean, if the host machine destroy, what will be the situation? So we can
Mhm.
persist our data in the cloud level also. That is advanced level
Mhm.
topic. But
Mhm.
we uh, in Kubernetes, we are having the PVC, PVPV, persistent value, persistent claim. So that is,
Mhm.
I'll be discussing the Kubernetes. So we can, I mean to
Mhm.
say that we can persist data in anywhere, locally
Mhm.
or cloud also. So most of the
Mhm.
people may store data on the cloud level if it is a critical
Mhm.
part when dealing the production level.
Mhm.
Mm. So, okay,
You
these are
mean
the,
that is not safer?
I didn't get you. What's that? Safe for me, of
You
course.
said
Right? Even if the even a host machine down, the data will be stored in the cloud machines.
mm,
Of course, it is safe here, right? Okay,
mhm.
fine. This is the Docker volumes. Another concept is Docker networks. Docker
Mhm.
networks. In Docker networks,
Mm,
we have a five networks. One, wait.
mm,
We have five networks. One is bridge network.
mm,
Another one is host network. Another one is none network, and overlay network, very important one. Next, Mac VLAN network. These are the five networks in the Docker.
okay.
So first one is bridge network. Bridge network means content to content communication. I mean, if you have a host machine and you created my containers, and the containers are defaultly connected to each other. I mean, you can ping one content to another content unless you create a different network. I mean,
Mhm.
it means basically on the host level. On the host level, you want to maintain the communication between the container. In that case, we can go for the bridge network. Another one is host network. In bridge network, each container will be having the one IP. If you create one
mm,
container, that will be getting 170.70.0.2, like that. When it will get the IP address for each
mhm,
container. But in host machine, it will get the IP from the host machine. Whatever the IP address having the host machine, the same IP will be assigned to here. So it will be used
mhm,
for the performance, because here, if you deployed an application inside the container and you want to access that application, you have to expose your application to the host machine. So the application need to pass to the container IP to the host IP. Understanding or not?
mhm. Yeah, yeah.
Your application is deployed in the container. If you want to expose your application, if someone try to access the application, that application needs to go from the container IP to the host IP, not directly to the host IP. You will be routing. We are accessing with the IP address, but backend it is happening. It is exposing to the container IP to the host IP. So there is a one
Mhm,
mediator. Container IP is a mediator. Your
mhm,
application is routing to the host machine, but in
mhm,
here directly we will get the host IP. So there is no need of a container IP here. So there is no,
mhm,
if someone try to access the application from the external,
mhm,
directly it is connect to the application. There is no need of container IP, direct communication.
mhm,
I mean, here a host IP is contact to the container IP talk to the application. There is
okay.
some latency, but here if someone try to access the application of Docker application, the whole host IP directly connect to the host application. No need of a container IP. That is a host mission. It is somewhat fast, but people don't use the
Mhm,
host IP. Next is a
mhm,
none network. If you don't
mhm,
want to share your network to anyone, you want to have some standalone or some orphan type container. You have some services which is only used for this container, not for the some other container. You don't want to make connection with another container. So in that case, you can go for the non network. I explained
mhm,
in session, just giving the overview. Overlay network is the most important network in any Docker or in Kubernetes, because we will be using overlay network only real time. Overlay
mhm,
network is basically host to host communication. See, you have containers in your host machine, and some other server also having a container. How you can connect to those content to other host machine container? So in that case, you can use the overlay network. Overlay network
okay.
like this. Any images here? Oh my gosh. Okay, chill. Let me open this. See, here is one host A, host B. These are the servers, different servers. Here my containers
Mm,
are there, and host B also have containers. I want to make connection with another host machine container. In that case, you need to use overlay network. So in Docker network, overlay network is ingress network. So ingress
mm,
network will be used by default. So ingress network is a overlay network. So it will ingress network will be created when you create a overlay network. So that is
mm,
next one is MAC VLAN network. MAC VLAN network is a physical network. Where I was diagram. Yeah. So MAC VLAN network is a physical MAC address. Do you know ISO model, Ravi? I mean, when we
yeah,
send
yes,
any,
mhm,
when we send any request to the
mhm.
another
There are
server, it will pass to
mhm,
the layers,
yeah,
physical
physical
layer,
layer
data
to
link
network
layer.
layer,
So
application layer.
IPs are basically host to. I mean, if you want to talk to the any other server, the
Mm,
communication will be passed to the IP address. That
mm.
is obvious, right? Everyone knows. I mean,
Yes, yes.
if you want to connect to your server, I will use your IP address. So
Mm,
uh, MAC VLAN is a physical network. Physical, even though we are
mhm,
dealing with the IP address, but IP address
mm,
must talk to the MAC address only. MAC address is
mm,
a unique. Each server will be having, each electronic device will be having the unique MAC address. Even your phone
Mhm.
will be having the MAC address, your laptop also having the MAC address for every device. So
Mhm.
your if I take example, real example, uh, your laptop your laptop with the router doesn't talk with the IP address. Your router and your laptop will talk to the MAC by through the MAC address. IP, your IP is, I mean, you will get the public IP. Definitely, you will get the
Mhm.
my public IP. Oh, my IP address. See, this is my IP address. Who is
Mhm.
assigning this IP address? Your router, your internet ISP, whichever the
Mhm.
router you're using that. This is not constant. It will change by the time. Like I don't know how much, one for every hour or maybe half an hour. I don't know. For for every device there will be having IP. Even your phone is you are able to access the internet means you will be definitely having the public IP.
Mhm.
See, okay. So here IP who is providing ISP. Your ISP is your router, internet gateway.
Mhm.
So, where is the internet gateway? Your router is internet gateway because your
Mhm.
traffic is going from internet. I mean router,
To router.
Wi-Fi. Yeah, Wi-Fi, right? So your
Mhm.
system to the router, the communication is not to pass through the IP address because
Mhm.
router doesn't know the IP address. It knows only MAC address. So your laptop MAC address, because you see, if let me give you the reality. See, for the router, number of people will be connected, right?
Of course.
Of course, kada. So if
Mhm.
number of people will connect, how does no? I need to give, if some user requested some, I want to open a google.com. So
Mhm.
you're sending request to the router, internet gateway. So and the response, how the response, it is connect to the router, connect to the Google servers. The response will be getting back. So router will
Mhm.
say, how does router know that who is requested google.com? Because one multiple users are connected to the same router.
Yes.
So if the request, if I requested, how does know how does know the router that I this response should go to the this user only? Because the MAC address, each device will be having the MAC address. IP
Mhm.
address is only used for the internet to communicate to router to
Mhm.
the some other server, which are the request you're passing. If you are
Mhm.
requesting the facebook.com, it will go to the Facebook servers. If you are requesting the Google, then it will go to the Google server. In that case, IP will be used, but response will be come from the MAC address. Router will know the MAC address of every device. See, in uh, see, if my router connected to the three devices, one is phone, one is a laptop or some other laptop. So
Mhm.
each device will be having a MAC address. That MAC address, no, router knows. So whenever we send any request to the internet, then router will get the response and sending to the corresponding device. Which device, how, from which device it got the response? From MAC address. So MAC, if I type google.com, then it will send it to the router. But not only the request, it will the request, your laptop will send your MAC address to the router. In the same way, response also sending back to the using the MAC address, not IP address. So here the so router to the server communication will be done through the MAC address. So MAC address is physical device. So here whatever we are getting IP address to the container, those are the logical IPs. Those are the logical IPs. But you want to make your container as this physical network. When you want to make container, I mean, the by using IP address, we can make the load balancing part. So you want to make just like a VMs, we can able to see right on the console, VMs, VM1, VM2, VM3, but containers we can't
Sure.
see on the dashboard unless you
Mhm.
going to getting inside the container. But those are the container IPs are logical IPs. They can't be useful anywhere. For
Mhm.
external world we cannot use that IPs. But you want to make utilize your container IP address, you need to create a MAC VLAN network, so that you can use, I mean, that container will be exposed as a physical network, physical device. So that IP can be used for the load balancing purpose. So this is high level. No, don't worry. We are in the real time. No one will use Mac VLAN. I'm just saying for the knowledge purpose. No one explained this Mac VLAN. So, but I know what I say. I'm saying what I know. Okay, these are the Docker networks. So in interview purpose perspective also people will uh, uh, this is a common question, what are the Docker networks? You can say people usually say four networks only. they
Bridge
won't,
host, none, Mac.
they won't consider none network, they will say four
Mhm,
networks only, but you can say five networks: bridge, host,
mhm,
none, overlay, mac peer network. So like then when it now comes to the Docker Compose. So here we are creating one container. I'm creating CentOS one container. I'm creating Nginx container. I'm creating some other containers. But you want to create multiple containers at a time. You can use the Docker Compose. In Docker Compose, you can create, you can write multiple images. Docker, Docker, documents, Docker file, Docker Compose. Yeah, Docker Compose example. Here we can create multiple images. These are services. Under services, this is one. I mean, it will create a one container by the name sample. This is another container. This is another container. So you can create multiple containers inside a Docker, whatever you want to mention, just like a Docker file only. But
mhm.
in Docker file we can able to create one image only. But in Docker Compose we can create multiple images. Not only images, we can directly create containers, multiple Docker containers in single Docker Compose. See, you have you want to create a infrastructure like with the applications or application container or database container, backend container. So why you will need to create individually? So you can create, you can mention those services in single Docker Compose file. Just run the Docker Compose up. That's it. It will create within seconds your three containers. Not only three, how many containers you want to create, you can create as many containers. There is no restriction like that. You can
Okay.
use the networks also, you can attach volumes also, just like whatever we can do in the Docker file, those can done in here, like that Docker Compose. And there is a one basic point. uh, uh, Most people doesn't know what how Docker works. I mean, how Docker contains making isolation part. Individual, how the containers work individually without depending on
Mhm,
other container. If another container is getting issue, why it is not affecting the corresponding the container. So this is a basic one, very important one. Actually, Docker works on the three major points. One is C groups, another one is mm, C groups, another one is files. Sorry, net. What is file system. The third one is volumes, I think. Yeah. So C groups is the most important part where how Docker can be isolated. See, even Dockers are creating on the host machine. We are not assigning any CPU or any RAM or any resources. We are not assigning anything manually. But how does Docker get the minimum resources? We are deploying our applications, we are creating some service files inside the Docker container. But obviously there it has to obviously it is storing on your host machine only. It is not creating on the cloud, right? You are creating containers in your host machine, obviously it has to be stored somewhere. So how this connection is established? So this responsibility done by the C groups file system volumes. C groups is useful for when you create a container. That container should get minimum resources. Minimum, this container should have this minimum 100 MB RAM. This container should get at least 10 cores. At least this container should get this kind of network. Right? I mean, we are not doing anything, but it is take caring by backend. Who is take caring? The C groups. C groups mean C groups. Understanding or
mhm,
not? I mean, Docker is isolating the container individually, but who is doing means this C groups Docker. Actually, it is doing by the Docker daemon. So how Docker daemon is communicating to the host machine? You may get doubt. We are creating CentOS. VMs directly. We are able to create a CentOS, Ubuntu. I mean, um, cre- I mean these images, right? CentOS, Ubuntu. If you download from the internet,
A
but
different kind of
images we are downloading. But how this can be happening? I mean, each image, if you download each image, will be having 1 GB or 2 GB or 3 GB RAM or ISO file. I'm talking about ISO file. But how fast, if you install any OS on your system, it will take 2 to 3 hours to install your OS. But how Docker containers are creating within seconds, right? So this
hmm,
Docker works on the Linux system. Linux Docker works on the backend. Docker's created in if you create any container, if you go inside that container, you will be using Linux commands only. So how fast it is creating means, because your containers sharing your host machine. See, if you want to create any CentOS container, I'm also using the CentOS, some Linux flavor only. So already all functionality will be having on my host machine. So what, when we are creating container, it will download only are not available. Only those dependencies not available on your host machine. See, if I create a container, Nginx container, if I want to create an Nginx container, I don't have Nginx container services on my local host machine because I haven't installed anything. So when we create a container, it is creating with a fraction of a second because the in the backend, it is already sharing all the dependencies already having in the host machine. Why it should download again existing dependencies? It will directly share from the host
hmm,
maker because in host machine already 90%, 95% dependencies already available on host machine. It will download only which is required to handle the things. Getting? So
yeah.
uh, C groups. So if I talk about C groups, so each container host Docker daemon will decide how much content, how much memory, how much CPU, which network should assign to the container. That is handled by the C group. C groups for each container, C groups will be created. And another thing is file system. Uh, have you ever tried attaching Windows volume to the Linux?
No, I didn't try that
because
on.
because those are
I
different
just tried
file
for
system.
attaching Windows to Windows. That's it, I
Yeah,
think.
because those are same file system. Same.
Hmm.
Because in Windows, NTFS, have you ever listened NTFS file system?
Yes, it's NTFS. I listened.
NTFS file system. So Windows will be having the NTFS file system.
Mhm,
If you attach any drive, external drive to that server, it should be NTFS file system only, because those are both should be in the same page. And if those are not in the same file system, it cannot communicate to the each other. See, if I know Telugu, you know some Bengali.
mhm,
There is not mutual language to talk to you, right?
mhm, mhm,
Same with the file system. So if I attach
mhm,
the same file system, then only I can communicate. I want to create a file or I want to copy the file. So it has to be same language. Unless
mhm,
we don't have the same common language, it cannot be
mhm,
understand if you do any functionality on the drive. So
mhm,
Windows having the NTFS, Linux having the
mhm,
ext3, ext4 file system.
mhm,
Right? So containers
mhm,
creating, we are creating containers. So containers also having the some file system. So that container is need to talk with your host machine. So there should be common file system to talk to your container. Your data need to be stored in your local host, local machine. There should be some same file system. So that, so it will take your host machine file system. Understanding
yeah.
how Docker is communicating, how Docker is storing your files into your Linux machine. So that is through the file system. So it will talk, your containers is creating, okay, but the backend functionality is running on your host machine only. How this is running? C groups is just for responsible to create, give the resources, RAM or CPU, any other. But talking about storing data, so there should be some common language. So it will create a common file system, Docker to the host machine. So this is handling by the Docker daemon. Docker daemon. See, uh, have you ever listened bare metal?
Bare metal.
Yeah, I think you should listen when we are doing
Yeah,
our
yeah. bare metal is there in
So
VMware.
to create virtual machines, first we will install one bare metal OS, the like VMware OS. Upon that, we can able to create a VMs, multiple VMs. So on your host machine, on your Windows, you should install some bare metal OS so that it can able to create multiple VMs. VMware workstation, you know, right? VMware workstation.
Mhm.
So on Windows, you are installing VMware workstation because you need to install your VMs. You need to create multiple VMs. So here bare metal is VMware workstation. It's a mediator. It's a mediator to create VMs. Same here, Docker daemon is a mediator to create a container. So Docker daemon knows the language of container of content to the host machine. They can communicate with the Docker daemon mediator. So the Docker daemon will so containers will communicate it through the containers and host machine should be in the same page, like connect same file system. C groups is just for response to create give providing the resource, and next one is volumes. So volumes means your content need to store some in some storage in some directory. So that is handled by the volume. So mutual common language is file system, common language. To store the data into the host machine, there should be common language, that is file system. And storing the data onto the local machine, that is handled by the volumes. So these are the three components. Because of three components, Docker is able to isolate the containers on the same host machine. Getting?
Oh yeah.
So next, when it comes to interview questions are like uh, an interview question. Yeah, here only. So basically, they will ask, this is the common question: what is Docker? Difference between VM and Docker. So in VMware, we need VMs are high, uh, heavyweight servers, but Dockers are lightweight because all the dependencies are already available in a local machine, host machine. Only which are not available services, those only download. That's why Docker containers are very fast to create the containers. How does Docker? I told you, C groups, file system, C groups, file system, uh, volumes.
Well,
Explain Docker architecture. Oh, I forgot to say this last. So whenever we download the image, Docker pull image name. So it will try to fetch from your local machine. Any context we have created. So if I try to create a download the image Docker image, Nginx image, if it is present on local machine, then it try to use the local system image only. If there is no Nginx image available in your local machine, then it will try to download from the Docker Hub. Docker Hub. So basically, I mean, Docker build means to create the customized image. I mean, you write to Docker file, right? Whatever the resources you want, you'll mention all this in Docker file. So you want to convert that file into the Docker image, you'll be using Docker build. Docker build it will create the Docker image. So yeah, Docker pull is to download the images. Docker run is used to create the containers, like that. So whenever you create a container, it will first that image, you will be giving the image name, right? So that image will check from the host machine. Is there is any Docker image is available? Suppose if I want to download create a Ubuntu container, first it will check Ubuntu is available in the local machine or not. It is not available, then it will connect to the Docker hub and download to the local machine. Then a container will be created. So everything is managed by the Docker daemon. Response to create all the infrastructure is handled by the Docker daemon, like that. So Docker file is a first stage of any Docker container. First Docker file, then Docker image, then Docker containers. These are the three stages. That is about the Docker. Yeah, Docker file explained, customized Docker image. Everything is, if you watch the videos, you can understand this. Understood, Ravi?
Yeah.
Mm. If any doubt, then I mean, I think that this is first class.
Yes, Ricky, I understood, and yeah, good. And I have to go on go
Obviously,
through
this is the first
those
class means.
all videos for depth
Yeah,
understanding and
mm,
clear the things.
yeah, yeah. So go ahead with that.
Sure.
If you have any doubt,
Mm,
then get back to me. I will upload
sure,
these
sure.
videos in
From
YouTube also. Don't worry. You can
sure,
share
sure.
it to your
Mm,
friends if you like the session.
mm.
Okay.
Sure, sure. Definitely, I
Okay.
will share that.
Bye, Ravi. Okay.
Mm. Okay, bye bye. Take care.